What's up, guys? Here we go. In this video, we're going to talk about how we actually go about graphing these polynomial functions, whether it's a linear one, a quadratic, a cubic, a quartic, it doesn't matter. We got the general idea, you know, if it's an even-powered polynomial function or odd power, we know about end behavior, but we're going to piece it all together, and now we're actually going to specifically graph these things by using direct or synthetic substitution to get our values, take them and put them in a little XY table, a nice little a chart, and then graph them, specifically plot them, graph them on the coordinate plane, and then graph it up and show what the graph looks like. So here we go. Let's dive into it. So as a reminder for you, any even degree, for example, like this, if it was anything that was, why is it not ready? Hello, here's why. X squared. So if it was a quadratic, we know that any even degree polynomial follows the rules of the quadratic. So if it's x to the 4th, if it's x to the 18th, it doesn't matter. If it's an even degreed polynomial, this guy right here with the leading coefficient positive, you know, remember the parabola goes up. It's a smiley face like that. If it is a negative leading coefficient, like say for example maybe negative x to the 4th, then you know it actually will go down, and it might bounce around up here a little bit like that, whatever. A 4th degree may look something like that, but at least it's going down. So even degrees, remember, went up if it was positive leading coefficient, and went down if it was negative leading coefficient. Odd degrees, those guys, excuse me, example like x to the 1st, x to the 3rd, x to the 17th, whatever, x to the 1,223rd power. Yeah, you'll never do something like that, but whatever. That's an odd degree. All of these graphs follow the same rules as the linear function, in that the slope of a linear function, if it's positive, you remember it goes up from left to right like that. Might be steep, it might be less steep, but that's at least a general rule. It's a nice straight line, moderate, good job. If it's this one with an x to the 3rd, remember it would go up like this. Now it would start down there, the same spot, and bounce around, maybe and come back up like that. But at least it follows the positive trend of a slope. And now I'm not saying that, again, cubics have slopes. Don't misunderstand me, but it has the same concept. So now, of course, if this was a negative, then it would start up here and have a negative connotation or I guess, path, like that. And remember, the other thing with end behavior, as the x value approached positive infinity, this guy right here, the f of x, was approaching positive infinity with an odd degree. Likewise, over here to the right, as the x value approached positive infinity, oh my goodness, sorry, hold on, back up. That is wrong, people. As the x value approached negative infinity, there you go, did you catch that mistake? Then the f of x value approached positive infinity. And now we're on track. As the x value here approached positive infinity, the f of x value you see is going down to negative infinity. So that's all end behavior. But all this pulled together to kind of start graphing these things like this up here. So on your graphic organizer, it's graphing time. We're going to do this, graphing these polynomial functions. And notice it says this. It says either by using direct or synthetic substitution. It doesn't matter which one, but we're going to use either one of these to fill out this chart to get that one, to get this one, this, and then plot those again over here on the coordinate plane. So that's a general idea, and again, here's the scoop. You see this particular one that we're going to graph is a 4th power. It's a degree of 4. It's a quartic. So you immediately, guys, should know, oh, if that's the case, well then I know since it's a 4th power and the leading coefficient is positive, I know it's going to look something like this. Something maybe like a W. Might not look exactly like that. Might come down and maybe flatten out a little bit like this and then come back up. But it's at least going to be a smiley thing or a W because of the leading coefficient that's positive. So let's actually get these actual points here and put them on the coordinate plane and see what in the world happens with this and how it looks. So I'm just going to move this up a little bit so we can have more room. Okay. Now, again, I'm going to use synthetic substitution just so I can kind of give you another gauge and idea about how synthetic substitution works. But here we go. Synthetic substitution to figure out the f of x values when the x values here are generated for you already. Notice we're kind of centering everything around the origin here where we're starting with 0 and then going 3 to the right and 3 to the left. Okay, it'll get you the general idea of how the graph's going to be shaping up. Although you know this is a quartic, so it looks like a W-ish type shape. So let's do this. So synthetic substitution. I need to put this in standard form. So I go x to the 4th. And then I would go, oh, there's no x to the third term, so I would go plus 0x to the third. I need that place value still held there, remember. I have a squared term, so it's negative 2x squared. I do not have an x to the first, so I need a placeholder for that, so plus 0x to the first, and then a constant of 4. So I will make my little chart for synthetic substitution. I'll put the coefficients. There's a 1, there's a 0, there's a negative 2, there's a 0, there's a 4. I'm going to pull this down right there and get it ready because that always is going to be 1. And then I'm going to add this to whatever I get here, add this to whatever I get underneath it, add. So there we go. We are ready to rock and roll and put the negative 3 in here and bounce it up, negative 2, negative 1, and bounce it up. So let's do it. Let me change colors. I'm going to put this negative 3 right over here, and I'll start bouncing. So negative 3 times 1, bounce past up to get me negative 3. I'm going to add this together and get negative 3. I bounce past again. Negative 3 times negative 3 gives me positive 9. Add these together, gives me positive 7. Bounce past again. Bing, bing. Bounce it up. It gives me negative 21. Add together gives me negative 21. Bounce past for the last time. Negative 3 times negative 21 gives me positive 63. And I add these together, and it gives me 67. Beautiful. So one of my one of my actual points is negative 3, 67. Beautiful. So let me clear this out. And now let's do negative 2. So I'll put negative 2 right there. I got everything set up already. It's all ready to go. So negative 2 times 1 gives me negative 2. Add them together gives me negative 2. Multiply gives me 4. Add that together gives me positive 2. Multiply that gives me negative 4. Add together gives me negative 4. Multiply that gives me 8. Add this together gives me 12. So one of my other points is negative 2, 12. Beautiful. So what I want you to do is keep going with your synthetic substitution here and fill out the rest of this chart. You can actually pause the video and then you're going to come up and see exactly what I got here with the rest of these things. Okay? Did you pause the video? Pause it. Work it out. Come on. Be persistent. You can do it. You didn't pause it. I'll see you. So there you go. So I got negative 1, 3. I got 4. I got 3, 12, and 67. Now, side note, just so you're very, very clear. You need to make sure you do synthetic substitution for every one of these or direct substitution for every one of these because they all don't work out this nice. Notice this is very symmetrical. It goes 67, 12, 3, 4, 3, 12, 67. Very symmetrical. I've also taken the middle points from here, negative 2 over here to 2, and I've plotted those on my coordinate plane. You can do that if you haven't done it already. But what I want you to notice is this. These last ones right here, I'll kind of star these. The negative 3 and the 3, typically, guys, they're going to fall way off the graph. I know you're going to say, I can't graph negative 367. You're right, you can't really with this grid because it goes way up there. But it does give you the idea and the verification in your own mind that that's where the end behavior of this particular graph is going to go. Because remember, it's looking like a, over here, whether it's the, the U shape or the W shape, it's going to go like that. So you at least know it's going to keep going up in that direction, which would make sense because it's going to keep going up there. So how do I graph these accurately? Well, you can kind of see how it is kind of making a W. But you always want to graph these things from left, always, to right. Just like we write any word in the English language, we go left to right. So you start here at this dot and you connect the next dot that's over. Not this one, not this one. The next dot that's over is that one. So I'll take this particular ordered pair and I'll pull it down here, really nice and slow. And I'm going to bounce off of this one, keep going to the next dot, bounce off of that one, go down to the next dot, bounce off of this one, and then come back up very sharply like that and draw my arrow like that because it keeps going that way and it keeps going that way. So the exact amount of turning here, how it's going to go, is kind of a little, you won't be exactly precise with it. But what you can at least know is, I know it's going to be a W shape or at least a flattened out, U shape, whatever. And you know it's going from left to right. Both of these end up in the positive infinity direction because of the rules that we talked about with end behavior. So that is how it rolls. Now here's what I'm going to have you do. Go down to the second one. Whoa, let me pull it up here a second. Go down to the second one. And you take this one and you graph it yourself. So be careful, though, of this negative x to the third. If you're going to use synthetic substitution, That's phenomenal. I'm going to show you really quickly how to find this one by using direct substitution. And here's how I would do it. If I'm taking negative 3 and putting into this, I would put negative and then in parentheses, I'm going to put whatever x is because that's what's going in for x right here. So it's a negative 3, so I'll put a negative 3 in there for x just like that. I'm going to recommend you do the same thing if you're going to do direct substitution. Then I would do the exponents first. Don't you dare take the negative times each other yet. Nope, that's not the order of operations. Your Aunt Sally would not be happy. So you got to do negative 3 to the third power, which is negative 3 times negative 3. Negative 3 times negative 3 gives me 9. Then I got to take it times negative 3 again, which gives me negative 27. So this right here, in parentheses, goes to negative 27. Don't forget, I still have this negative outside of there, and I got this minus 2. So now, since I have no exponents, I have nothing in parentheses, no exponents, now I can do this multiplication of negative 1 to that negative. So negative and negative.